Hi everyone, I am Professor Shalini. Let's start with new concept of Term 2. In unit number 4 we have seen governors, their functions, different types of governors and various properties of governors. Let's move toward next point, that is flywheel. In this topic we will see what is flywheel, its advantages, disadvantages, again what is effect of turning moment diagram for flywheel, then what are fluctuations of energy and speed for flywheel. Again we will determine flywheels for different size and different types of engines and machines. Okay, let's begin with introduction to flywheel. We will first see what is flywheel. Okay, a flywheel is a heavy rotating body which acts as reservoir of energy. It is nothing but a storage of energy. Okay, it acts as bank of energy between energy source and machinery. It is nothing but energy bank which is between energy source and machinery. Energy stored in flywheel is in the form of kinetic energy. The form of energy which is stored in flywheel is kinetic energy. Okay, flywheel is a rotating mechanical device that is used to store rotational energy, and the rotational energy is stored in flywheel in the form of kinetic energy. Flywheels are typically made up of steel and rotate on conventional bearings. Okay, these are generally limited to a revolution rate of few thousand RPMs. Okay, but some modern flywheels are made up of carbon fibers. Okay, and they can revolve at a speed of 60,000 RPMs. Means new flywheels can rotate at very high speed, that is up to 60,000 RPMs. Okay, we will see few pictures of flywheel. This is one type of flywheel and this is another type of flywheel. Okay, now we will see how flywheel works. Okay, what is working principle of flywheel. Okay, the flywheel connect the rotation from engine to clutch plate to transmission. Okay, the flywheel also make the crankshaft become move in a motion to make engine work from starter. Okay, this is also example of flywheel. Then what we can say, what are functions of flywheel? It is used to store energy when available, and it supplies energy to machine when energy is required. Okay, due to this energy provided when required, the speed fluctuation gets reduced. Okay, these flywheels are also used to reduce power capacity of engine, motor, electric motor or engine. Means what? It is used to reduce power capacity of engine. Okay, now where is the location of flywheel in a car? Flywheel is located between the engine and clutch plate or clutch pad to starter. Okay, now these flywheels are also classified into two main types, and this is based on angular velocity. Okay, first flywheel is high velocity flywheel, second one is low velocity flywheel. In high velocity flywheel is designed for angular velocity between 10,000 RPM to 100,000 RPM. Okay, and low velocity flywheels, these low velocity flywheels are designed for angular velocity between 10,000 RPMs. Okay, we have seen positions of flywheel in a car. It is located between the engine and clutch pad to starter. Okay, these are few examples of flywheel. When do we use this flywheel? this flywheel is used when before engine on if we start the starter. Also it is used to forward rotation from crankshaft to clutch. Okay. Now we will move towards history of flywheel. The principle of flywheel was found in Neolithic spindle and potter's wheel. Okay. In Industrial Revolution, James Watt contributed to development of flywheel in a steam engine. So during Industrial Revolution it was found in steam engine. Okay. And his contemporary James Pitchford used a flywheel combined with a crank to transform reciprocating into rotary motion. What is basic difference between flywheel and governor, which we have seen in earlier lecture? As we all know, the energy stored in form is kinetic, which is 100% available, but in governor friction is involved. Okay, in governor friction is involved. As we all know, if we have constant load, then governor will remain ideal, but due to cyclic fluctuations in energy, flywheel will always work. Okay, governor has no influence in cyclic fluctuations in energy, whereas this flywheel has no influence on mid speed of engine. When the engine speed is at mean, this flywheel has no influence, whereas when there are cyclic fluctuations in energy, governor will have no influence. Okay, actually governor is used to control the mean speed of engine, whereas flywheel is used to control fluctuations in energy. Okay, last, a flywheel is used to mitigate cyclic fluctuations in energy, but this governor is used to supply the fuel as per load. If load increases, engine speed decreases, and this governor supplies the fuel, increases the required amount of fuel so that engine speed can be maintained and engine speed increases. What are advantages of flywheel? As we all know, the overall cost for flywheel is low. We can get high power output. Again, this flywheel is safe and energy efficient. This flywheel has low cost, low and inexpensive maintenance. It has low cost and high energy density. We can also say that in a flywheel energy storage is more. Okay, now we will move at last point, that are limitations of flywheel. As we all know, flywheel occupies more space. It is expensive to manufacture. Okay, thank you.
Hi friends, I am Professor Shalini Tarvade. Let's see next concept of internal combustion engine. We are discussing about flywheel in last lecture. Now we will move towards turning moment diagram and flywheels. Okay, first we will see turning moment diagram for 4-stroke IC engines. Okay, before that I will explain you about turning moment diagram, which we have already studied in mechanics SOM. Okay, turning moment diagram is generally a graphical representation of turning moment or torque. Okay, as we all know, torque is given along y-axis versus crank angle, which is generally represented on x-axis, and it is for various positions of crank. As it represents various positions of crank, it is also called as crank effort diagram. Okay, from the figure we can see that here on y-axis turning moment is represented and it is given by theta, and here on y-axis crank angle is represented, various positions of crank is given, and it is called as crank effort diagram. Okay, it is plotted on Cartesian coordinates. Okay, as we all know, taking ordinate as turning moment and abscissa as crank angle. Okay, now why we use this turning moment diagram? We use this turning moment diagram so that we can obtain variations of torque which indicates the size of flywheel. Okay, More than one curve indicates multi-cylinder engine. Okay, it shows this turning moment diagram also shows variations of turning moment with respect to various positions of crank angle of an engine. Okay, it also indicates more variation, or when there are more variations it indicates larger flywheel. If less variation indicates small flywheel. Okay, since the pressure inside engine cylinder is less than atmospheric pressure during suction stroke, therefore negative loop is formed. In diagram we can see negative loop here. Why is this negative loop? Because pressure inside engine cylinder is less than pressure outside, that is atmospheric pressure, whereas in compression stroke the work is done on gases, hence high negative loop is obtained. Here we can see that this is suction stroke, this is compression stroke, this is working stroke, and this is exhaust stroke. Okay, from this we can see that in compression stroke, as work is done on gases, therefore high negative loop is obtained. Here we obtain high negative loop. Okay, during expansion stroke, as we all know, fuel burns and gases expand. Okay, hence positive loop is formed. Here we can see that high positive loop is obtained. Okay, and this gas stroke work is done by the gases. Okay, in last stage, that is in exhaust stroke, work is done on gases, and therefore again negative loop is formed. And last, in exhaust stroke or exhaust stroke, here work is done on gases, so negative loop is formed. This is turning moment diagram for 4-stroke IC engine. Okay, first negative loop due to compression during compression stroke, then big negative loop during compression stroke, then during working stroke or expansion stroke we obtain positive loop. At last we obtain during exhaust, as work is done on gases, we obtain negative loop. Okay, now we will see next. Here we obtain expression that is T is equal to Fp into R in whole bracket sin theta plus sin 2 theta upon 2 under root n square minus sin square theta. Here this Fp represents piston force. Okay, and here R is radius of crank, theta is angle turned by crank from inner dead center, and theta and n represent ratio of connecting rod length to radius of crank. Okay, I will repeat formula again. Here T is equal to Fp into R in whole bracket sin theta plus sin 2 theta upon 2 under root n square minus sin square theta. Okay, from this expression we can see that turning moment is 0 when crank angle theta is 0. From this we can see that turning moment is 0 when crank angle is 0, and its maximum when crank angle is 90 degree. When crank angle reaches 90 degree, then we can obtain turning moment as maximum. Again, when do we obtain turning moment maximum? When crank angle is 270, and when we obtain turning moment as 0 when crank angle is 180 degree. Okay, and 360 degree. Okay, from this we can see that in curve ABC it represents turning moment for outstroke. Okay, and curve here curve ABC, small ABC, this curve ABC represents turning moment for outstroke, and curve CDE represents turning moment for instroke. Okay, outstroke and in stroke. Since work done is product of turning moment and angle turn, therefore the area of these turning moment diagrams represents area or work done per revolution. Okay, it represents area or work done per revolution. Okay, next we will see turning moment diagram for multi-cylinder. Okay, as we all know, a separate turning moment is there for multi-cylinder engine. Okay, for a compound steam engine having 3 cylinders and resultant turning moment diagram we can see in figure. Okay, here we can see that first cylinder is high pressure cylinder, second is intermediate cylinder, and third cylinder is low pressure cylinder. Okay, therefore the cranks in case of 3 cylinders are placed at 120 degree from each other. Okay, here they are placed at 120 degree from each other. Okay, the resultant turning moment diagram is sum of turning moments for 3 cylinders. Okay,